My name is Ajaz Mustafa.
Myself, Mohammad Tanzeel Adam Khan.
I am Mohammad Sakir Hussain.
Together, we are working on logic minimization using Espresso.
Instructed by Dr. Arijit Mondelso. Let's get started. In this video, we are going to talk about logic minimization using Espresso. Before further ado, let's talk about the topic we are going to cover in this video. About the introduction, what is AI, why we use logic minimization, historical context, key concept, what is the Espresso algorithm, steps in Espresso algorithm, types of logic minimization, role of Espresso algorithm in digital design, case studies using Espresso in digital system, real world application, ethical consideration in logic optimization, and many more. So in this video, I'm going to talk about introduction, what is logic minimization, historical context, key concept, and basic difference between method and heuristic search. So let's talk about what is AI. As you all know, AI is a very buzzword as of now. People are talking about AI everywhere. It's like something new, something very buzzy, and people really want to dive into it. So AI is basically able to think like a human. If we feed some logic, if we feed some data, it is able to act like a human. It's not able to act like a human basically, but at least take decisions like how we human take. It learns from the data, it makes work easier, and also it is used everywhere. Like in our daily life, we use ChatGPT to learn some data, to gain some knowledge. If you want to generate some images, there are a lot of platforms which are able to generate some context, some graphics from like Llama, and ChatGPT even are able to now generate some images as well. So let's talk about the main topic, what is logic minimization. By the definition, logic minimization is the process of simplifying Boolean expression while maintaining their original functionality. It helps reduces hardware complexity, improves circuit efficiency, and optimize performance in digital system. The challenges which are faced by complex logic expression are it increases circuit size, and which also relies to the high amount of power consumption. It is slower in processing speed, higher manufacturing cost, difficulty in debugging and maintaining circuits. The major issue is scalability issues. So now let's talk about the key concepts we will be using in heuristic search, basically in Espresso. So we will be talking about Boolean functions, truth tables and minterms, logic gates and circuits, redundant logic and optimization, heuristic search versus exact methods, heuristic Espresso algorithm and heuristic optimization. So I believe most of the people are aware of this. If they're not aware, we would like to suggest to go through all these small topics. It will just take 5 minutes max to max. Now let's talk about the historical context. Early approaches to logic minimization. We were talking about exact method. Basically, before heuristic search, we use exact methods to discover some of the new cost or some functions which could minimize the cost. But after several tries, we were not able to make that computationally inexpensive something. So this was taking a lot of computational expenses. The need of automation, the development of Espresso. So we are going to talk about all these things in this video. Before further ado, let's talk about type of logical minimization. So as I was saying earlier, before heuristic search, we were using exact methods. So what is exact method basically? Exact method ensures a fully minimized Boolean expression but are computationally expensive. What they are, like we use truth tables, we use some circuits in our board to make decisions. But in K-map, it can take only 6 variables. So if we want to increase our circuit size, it was not able to perform very well. This is why exact method sometimes outperforms. Like Quinn-McCluskey algorithm uses a tabular approach to find prime implicants for larger function. These methods basically guarantee optimal solution but have exponentially complex. For large circuits, heuristic methods like Espresso are preferred. This is why I was telling exact methods were not able to perform in a very effective way. This is why heuristic method introduced Espresso. So let's know about heuristic search. Heuristic method use approximation for faster logical minimization. It is more scalable than exact method, ideal for large Boolean function. Espresso algorithm is the most used heuristic approach, uses expansion, reduction, and irredundant, covering for simplification. No absolute minimal, but form achieves high optimization efficiently. These are basically used in VLSI design, FPGA programming, and digital circuits. So, I would like to introduce Abhishek for some more further information. Thank you.
So thank you Tanjil for this beautiful presentation. So now I am going to explain further about what is espresso. So espresso is a fast algorithm for minimizing Boolean functions. Now you all would be wondering that what is Boolean functions. So Boolean functions are those functions which are helpful in representing logic gates like AND, OR, NOR gate. We use true and false value to denote this. So how does espresso help in reducing logic complexity? It basically keeps the functionalities intact, and by this way it reduces the logic complexity. It also optimizes circuits efficiently using heuristic steps, which we will see later on. So what is espresso algorithm? Espresso algorithm is a heuristic based logic minimization technique developed at the University of California in 1980s. It efficiently simplifies Boolean functions, making it ideal for large scale digital circuit design. So the flowchart of espresso algorithm is given here. Now let's come to the board.
We know the exact method. It means K-map. In the K-map, we are exploring all the possible of prime implicant. That takes, when we are exploring all the possible prime implicant, it takes lots of time. When it takes lots of time, it goes in exponential time. That make slow our system for minimizing the power consumption and make faster our system. We understand, we are going to understand espresso. In espresso, we are instead of exploring all the nodes, all the term prime implicant, essential prime implicant, we are exploring here only step by step. After first step, we expand the term, then we are expand, and after that we reduce the redundant term. We get the final minimization of our any equation. Now, here is the first step, that is initial. Just take an example of equation in the first step initial. Here we just combine a term as a prime implicant. This is one possible, this is the second possible, and this is the third possible, this is the fourth possible. Here is 4 prime implicant can be made, but this is not a minimized prime implication and equation. For minimizing this, we first do the reduce term. We reduce this term. When we reduce this term, it reduced to this one goes to alone. First step, when we reduce this, it goes alone. After reducing, we are kept here to expand. I mean, in the term of expand, we just find the neighboring sub part of this one. When we find the neighboring part of this one, there is a 2 options. First is in the right side, and the second is left. But we know, we are see here. Here is already it make a prime implicant with their lower part. So we go for the right part. When we make it right part, there is a new term introduced, that is irredundant. This is irredundant. Irredundant part means this is the extra term in our prime implicant, in our equation. When we remove this term, this is irredundant term, the logic, it doesn't affect in our logic. So we have to remove this irredundant term. When we remove this irredundant term, we have now the final prime implicant, that is a minimized logic. That is we have the only 3 prime implicant, and it is the essential prime implicant also. This is the final logic minimization for our equation. Thank you.
So steps in espresso algorithm. There are basically 3 steps in espresso algorithm. First is expansion, second is reduction, third is redundant covering. So the rules of espresso in digital design. What are the rules in digital design? Like first, it optimizes Boolean logic for efficient digital circuits. We can see that Boolean logic is being used always. So maybe there might be a confusion that whether it is in exact method or heuristic method. So let me clarify that Boolean logic we use Boolean logic to eliminate the functionalities. Like if we have 5 terms, then we can eliminate it using Espresso. So it reduces logical expression, minimizing the number of gates used, as I told earlier. Improves circuit performance by lowering power consumption and increasing speed. As we all know that in case of exact method, there was a large power consumption. So so the work of Espresso is to optimize the things. So it optimizes the power consumption, hence lowering the power consumption and increasing speed. It reduces hardware complexity, making designs more compact and cost effective. It is, in simple terms, we can say that it is more cheaper than exact method. It is essential for VLSI, ASI design, enabling large-scale integration. It uses a heuristic approach to handle complex logic efficiently. Like it uses a heuristic approach means with the help of heuristic methods, it can easily eliminate the larger terms in simpler terms. It is faster and more scalable than exact method. Widely used in embedded system. It plays a role in to accelerate things. Like it can be a AI accelerator to optimize logic for machine learning hardware. It is in short term, I would like to say that Espresso is a vital tool in modern hardware design. It also maintains accuracy as well as balancing efficiency. So thank you. Now I would like to invite Muhammad Sakir Hussain to further elaborate about this topic.
Thank you, Abhishek, to giving me chance to continue this presentation. And now I am going to cover 2 and 3 topic. The main topic is case study samples using Espresso. In the field, there is lots of field to implement Espresso like digital circuit, VLSI design, AI machine learning, network security, automation system, embedded system. In digital circuit, we are minimizing the Boolean algebra. In VLSI design, we optimize the hardware implementation for fast and cost-effective chip. In AI machine learning, reduce the computational complexity in neural network logic function. Network security, optimized encryption and firewall rule set for better performance. Automation system for simplifies control logic for industrial automation and robotic. In the last embedded system, minimize logic gate for power efficient and compact embedded device. And the next real world application, Espresso, in various centuries in era. The first time in 1950s, Boolean algebra was manually used before the Espresso. In Boolean algebra, we are using K-map for the minimizing our logic. In Boolean algebra was manually used to simply logic circuit in early computers, enabling basic computational efficiency. In 1970s, automated tool like the Espresso algorithm come to exist. When automated system Espresso algorithm come to exist, VLSI chip design come to exist second time, making to logic minimization faster and more efficient. In 1990, optimization logic function enhanced embedded system, leading to power efficient microcontroller and digital signal processing unit. At 2000 era, with the rise of AI, when AI come to existence, their automation system and logic minimization is very important to become crucial for robotics, traffic management and industrial automation. In now today's era, we are working on smart devices. It's come in existence 2020s. IoT devices, wearable technology, levered logic optimization for better energy efficiency, computational speed. And in the ethical consideration in logic optimization, there is three points very important. First is bias and fairness. AI system can inherit bias from their training data, which may result in unfair or discriminatory outcomes. Ethical AI require addressing and mitigating bias to ensure that AI systems are fair and equitable for all individual and group. Data protection, AI often relies on large data set, raising concern about data privacy. Ethical AI practices involve protecting individual data and ensuring transparency about how data is collected, used and stored. In the third, autonomy and control, ethical AI consider the degree of autonomy given to AI system and the control mechanism in place. Maintaining human oversight and control is important in critical decision making process. Now I am going to call Ejaz Mustafa to to conclude the last topic. Thank you.
Thank you, Mohammed Shakir. Now it's my part, and I will start with the implementation and its tool. The very first thing we are going to talk about is Espresso algorithm implementation. The Espresso heuristic logic optimization algorithm is widely used for simplifying Boolean expression. It is implemented in digital design software to reduce logic complexity while maintaining functional accuracy. What it want to say is that, like, you are talking about artificial intelligence. You are talking about artificial intelligence, that means you are talking about hardware and software. The software, that whatever you have built has to be embedded on the hardware, and that hardware, how it uses that's all about. So it is implemented in a digital design software to reduce logic complexity, that whatever the logic you have built in that, so it reduces that while maintaining the functional accuracy. Whatever the functions you have made, what are the functionality you have provided, it keeping in mind that maintain the function accuracy. Okay, the next one is the tools for logic minimization. There are lots of tools for the logic minimization. I will talk for a few. The first one is Espresso, a command line tool for Boolean function minimization. Like if you are dealing with some Boolean function minimization, you will use Espresso, a command line tool. Okay. The second one is ABC, that stands for Barclay Logic Synthesis and Verification Tool. The third one is Logism, a graphical tool for circuit design and simplification. If you are dealing with some sort of circuit design and its simplification, then you have to use a logism tool to express all these things. A graphical tool for circuit design and simplification. Like if you are dealing with some circuit design and simplification, as I told you why circuit design are used. So if you are dealing some sort of circuit design and simplification, you have to use a logism for its graphical representation, a graphical tool for this. Okay. The last tool for logic minimization is Quartz and Zinix, if I'm pronouncing it right, Zinix Vivado, used for FPGA and ASI design for logic optimization. What is FPGA? Field programmable gate array. It is a hardware circuit that can be programmed and reconfigured after manufacturing. Like if you have manufactured some sort of circuit and you need some configuration in that, so you can do after its manufacturing also. So that's come under the category of FPGA. The last one is application in hardware and software. These tools are used in VLSI, FPGA programming and embedded system to improve efficiency, reduce power consumption and enhance the performance of digital circuit. AI and this all digital circuits everything we will roam about its power consumption, like what kind of power, that how much power it is using, what is its power consumption, whether it enhance the performance or not. So that's things come under this. The next one is heuristic evaluation and usability testing. So there is this next slide says that you have to tell the difference between heuristic evaluation and usability testing. Here we will consider few factors. First is definition, participants, methodologies, bias consideration, remote feasibility and complementary nature. So I cannot explain all this because of the time bound. So I will explain only like few. An expert review. The definition for heuristic evaluation, an expert review for the interface against the established usability. And what is usability testing? The definition for this is real users performs to identify usability issues. What this means, that we are the real users of these things. We perform tasks on that to understand whether it's usable or not. Okay. The next thing is future scopes of Espresso. The first thing which come into this, like if you are working on something that keeping in mind that there will be some future scope of that as well. So there are the few things that I will consider. The first one is edge AI and Internet of Things. The second one is neuromorphic computation, AI acceleration and FPGAs. The fourth is autonomous systems, and the fifth one is quantum computing, AI hardware systems. Like if you are dealing with artificial intelligence, like you will see AI in the most field of your life. Whether you go for healthcare, you will see AI there. If you go for agriculture, you will see AI there. Like any sort of factor you will think in this era, you will find AI there. So neuromorphic computing, that means the logic minimization can enhance AI hardware inspired by human brain. When it comes to a human brain, that means we are talking about the neural networks, right? reducing computational complexity and spikes neural network. I hope you got this. So I will come to the conclusion part of this, the conclusion optimization logic for AI. Espresso plays a very important role in logic minimization. Why logic minimization? That whatever the logic you have built, it has to be minimized. Like if you build some logic that is consuming a lot of hardware, that is consuming like a lot of space on your hardware, ultimately that's not going to work. So how you are reducing your logic, that plays a very important role. And how you can do that? You can do with the help of Espresso. The thing next come to existence is digital circuits, how is scalable, and I have already told you everything, so I will just read you once. Espresso plays a crucial role in logic minimization, making digital circuits more efficient, scalable, and more cost effective. Why cost effective? Like if you use some less circuits, that will become cost effective. If you use number of more, then it will not become a cost effective. A heuristic approach balances accuracy, speed, making it time for complex AI driven hardware system such as neural network accelerator, edge AI device. By optimizing logic, Espresso enhance processing efficiency, paving the way of more powerful and intelligent computing solutions in the era of AI and automation. Thank you. I hope you all got this.
So I hope you like this video. Please, if you have any sort of query, you can reach us at our mail, which we have provided in the description box. Thank you for watching.
Thank you so much.
Bye.